I made a first-person shooter in a week. Now I know what you're thinking, but Liam, this is clearly a third-person shooter. To that I say, quiet you. We'll get to that later. But first, my name's Liam, I love video games, and I've got some pretty cool ideas for some of my own. The only problem? No clue how to do it. That's why I'm diving headfirst into game development, determined to build games from the ground up. This is the Devlog Prologue. Like any project, it's crucial to break it down into workable pieces. For a simple shooter like this, we start with some basics. Get the player moving, add in the animation, program the shooting mechanics, add in health and death mechanics, program enemy AI, then set our win and loss conditions. If you're wondering, the first hurdle has nothing to do with any of these steps. It's immediately realizing that the materials that we were using for the project were meant for Unreal Engine 4.25, and I'm working on 5.4. So if you've seen any of my previous content, you'd know that adapting to different versions could lead to quite a lot of learning opportunities. The first of such opportunities was losing the project immediately after it was generated. After a quick search, it turned up in one of my old project folders, drag and drop for an easy fix, and an early reminder that you're always troubleshooting. This project came with the demo map and some assets from Epic Games' cancelled Project Wraith Paragon, which looks pretty awesome, but the default character blueprint came wrapped in a dozen warnings and a critical error related to VR controls, which I didn't need for this project, so I got rid of it. The lectures kick off with some basic definitions and descriptions, like the differences in inheritance between pawn classes, characters, movement, and a quick introduction into navigation meshes. I made sure to keep detailed notes this time in my code template document, with mini tutorials on how to implement features again in the future. Every step, every bug, and every fix gets documented. This time with the addition of tags, so things are a little bit easier to find again later on, for when I inevitably forget. Then, I forgot how to create a pawn class in C++ in Unreal Engine. And to make it worse, when I did figure it out, my C++ classes weren't showing up in the editor. It was only my first hour in, and I was already on the verge of giving up. Turns out, I hadn't run the build in Visual Studio, but once I did, my classes popped up, and I quickly added that to my log for my first major crisis averted. Somewhere in the middle here, I also made a spelling mistake and called my shooter character Shooter Chatactor, with no clue how to rename it, and with a few lines of code already in place, I just opted to keep it. With the setup done and our chat actor in place, it was finally time to move on to step 1, player movement. Now, in Unreal Engine 5.4, axis mappings are technically deprecated, but for this project we built everything from scratch so we didn't need to rely on Unreal Engine's pre-made first-person controller. I really enjoyed the lecture mini-challenges and the troubleshooting process for the controls. I ran into an issue with the horizontal look controls. They weren't really working at first, but after tweaking the yaw input from the pitch input, things just started clicking. Bit by bit, my imposter syndrome faded as I connected the dots on my own, and for me, it was a sign that more than replicating the material, I was fundamentally understanding the content. Now, I got a little too excited and jumped back into my Toon Tanks project to try out my new pitch mapping skills, and well, it went about as well as you'd think. Still a success from a certain point of view. Now back to the main project. Step 1.5 was adding in some controller support. I learned that by default, controller sensitivity is directly linked to frame rate, which is variable between players, and it can be an absolute nightmare if you're trying to make a game multiplayer later on. So to keep the controls consistent between players, we mapped the controller to its own input set and then converted the sensitivity from frame rate into game time. With everything that I learned here, I'm pretty sure I could piece together an in-menu sensitivity option, but it's a little bit beyond the scope of the project for now, so I'm sure I'll cover that in a later game. Next up was animation, and boy, was it a lot to take in. We went from a basic walk cycle that never stopped to mapping a whole series of animation states, from idle to walk, run, jump, aim direction, death animations, airborne and grounded states, conditions and transitions, you name it. During the polishing phase, I took things a little bit further and added in a special death animation for when the character dies mid-air. He does a little bit of a front flip rather than just falling back. It's a small addition, but it's one of those things that helps it all come together. I'd really like to thank my friend at Studio for providing me with this time dilation function. It really helps troubleshoot small bugs in animation and character movement. On to the part that makes a shooting game a shooter. Shooting. Now steps 3 and 4 have a ton of overlap, so these sections can just be grouped up together in a shooting architecture. Starting off, I created a gun component in C++ and attached a handling point, so it could easily be attached to the character and swapped out for new weapons in the future. The root and skeletal meshes weren't loading in at first. Small mistake, I had the code in begin play and not the constructor. After another quick tweak, everything worked out as expected. The main issue I ran into here was when I was programming in the damage. The lectures were old, and they didn't mention anywhere that I needed to include damageEvents.h in the gun component. So I spent nearly an hour here trying to figure out why my code wasn't compiling. Google was my friend, and once I figured it out, the shooting architecture was finally complete. From there, hiding the default gun from the player character, attaching in the rifle, adding in particle effects, sound effects, and impacts, all went as expected without any issues. I also learned a lot about audio spatialization and the use of sound modulators. With only a 20% pitch and volume variation in a randomizer, I could turn a single sound into dozens of unique ones. Speaking of sounds, in the middle of recording this, I got hit with the entirety of the cold and flu season, 30 days of gross congestion, and a little bit of second puberty, which isn't the best for trying to record audio. So for the rest of the video, my voice might be a little bit different. Now, my progress this time was a little bit slower because every second thing that I learned went directly into the code template document, but in the end, I had a number of mini tutorials ready to go for when I needed them next, which can be helpful when it comes to troubleshooting or making games later on, but it's not exactly conducive to trying to finish the lectures in a timely manner. This brings us to step 5, AI. This was my first introduction into programming enemy AI. The section was pretty intuitive and for the most part went smoothly. It started out with setting up an AI controller in C++. From there I got an intro into behavior trees, blackboard variables, and navigation meshes, with just a few hiccups along the way. After adding the tick function, the AI stopped looking my direction and stopped tracking me after the first encounter. After 20 minutes of frustration, I realized that I didn't call to super in the tick function, which fixed the issue. But wouldn't you know it, 5 seconds later, the course lecturer found and fixed the exact same bug I did. If I would have just listened for another 5 seconds, I could have saved 20 minutes of frustration. But hey, it felt good to solve the problem on my own. The AI now tracked my location, followed and chased, but when it came time for combat, they'd explode and fall over. Originally here, I had a comment for not very cutesy or demure, but given the congestion time, I don't really think that's relevant anymore, so here's the sad hamster.
They ask you how you are, you just have to say that you're fine when you're not really fine.
The solution here was adding in parameters to the line trace to ignore self-damage, and voila, the AI was attacking properly. After adding in some additional polish, the blackboard and behavior trees were complete. The AI had a line of sight function where it would begin chase and attack, investigate the last known player location, and either re-engage in the chase if it saw me again, or go back to its starting location. Between the AI and win-loss conditions, I changed some of the code and the death function of my shooter chat actor to remove the collision capsule and detach the controller on death. This made it so when the AI pawns died, their lifeless ragdolls would stop sliding in my direction. Finally, on to step 6, the win and loss conditions. They were pretty straightforward. I set up a UI widget to reflect a win screen and a loss screen, but before you say anything, yes, they do look like they were drawn up in Microsoft Paint, but that's why we're learning. Also added in a HUD equipped with a health bar and crosshair to help out with some of our player characters' aim. I worked this all out during a live stream to the comedic realization that if statements and null pointers are actually pretty important. It'll be a null pointer. Will it crash the game? Yes, it did. On the code end, if all the AI are dead, you win. If you die, you lose. Instead of counting the pawns manually, I linked the AI controller to the win condition, so if no AI controllers are pinging back, you win. And as always, there was a little bug where both messages would play at the same time if any pawn died. This was fixed by removing an early return that I missed in the endgame function. Through all that, it was down to the final polish. I fine-tuned character health, adjusted animations, fixed an AI bug where they'd all charge in at once if they spotted the player character, and I even added a voice line randomizer, so 50% of the time, the AI has something to say when they spot me. I also went back to rewatch my own sound tutorial to figure out how to loop music properly, which is super embarrassing, but in my defense, that was before I started my code template document. Now it's 97 pages long, and I'm pretty proud of that, and of course, yes, it does include how to loop music. But the video's not over yet. Now, if you stuck around this long, you'd know this is supposed to be a first-person shooter, not a third-person shooter. And there you have it. It is now a first-person shooter. And with that, we've reached the end of the video. I learned a lot more than I expected during this project. Even more so, it highlighted what I've already learned and showed me that more than just replicating tutorials online, I'm fundamentally grasping the content. I'm solving problems on my own, being creative beyond the scope of the course, and little by little, I'm growing as a game developer. I hope you enjoyed the video. More to follow in the future, hopefully faster this time as I learn the art of video creation, video editing, and avoiding getting sick. As always, thanks for watching.